So today we will be creating a scatterplot and using LinRegTTest. So the table shows data collected on 10 randomly selected subjects. The subjects were asked to record the hours of TV watched and pounds of ice cream consumed in a 12-week period of time. We are interested in if there is a relationship between these two variables. Now, this was just made up data, so don't believe that any of this is true. This is just for demonstration purposes on how to use the calculator. So first things first, we need to put in our data into the calculator. And the way we do that is by going to the stat button, we go to edit, and then we have to put in the data in list 1 and list 2. Now list 1, I'm going to treat like my x's, my independent variable, which I'll treat as TV, I'll put in list 1. And then list 2, I'll treat as my y values. These will be the dependent variables. I'll put in L2. So I'm going to go stat, edit, and then notice I have data left over. So to clear out the data, you need to arrow up, hit clear, hit enter, and it clears it out. So hit up, hit clear, hit enter, it clears it out. Do not hit the delete button. You would eliminate the entire column, so do not do that. Alright, so now I will type in my data. So you can pause the video and type it all in on your own if you'd like. Alright, so all my data's typed in, and I can see that I am in the 10th row here, so I know that I've typed in all 10 of my data points for both columns, for both the x values and the y values, my independent variable and my dependent variable. Okay, so now I'm going to hit second mode and quit out, and now before I make a scatter plot of this, before I make the scatter plot, I am going to go to the y equals, and go to y equals and then arrow all the way down and make sure that just everything is totally cleared out. Now the reason behind this is so that no weird symbols are placed in here and nothing is interfering with the scatter plot that we're going to make. Okay, so just go to y equals, clear it all out. The next step, you need to hit the second button and then hit y equals. And second y equals brings us to the plot menu. And we are going to turn plot 1 on, so just hit enter, turn it on, and the default type is the scatter plot. So we're actually already done. Now xlist, that is what I determined to be list 1, and ylist I determined to be list 2. So you always put the independent variable in xlist and the dependent variable in the ylist. Now the marking, we have a square, kind of a plus sign and a dot. I'm just going to leave it as a square. Different calculators have different markings depending on how fancy a calculator you have. Now I'll hit second quit and I quit out. Now my plot 1 is on. Now it's on, so if I go to y equals, you'll see that it's highlighted up here. It's highlighted, plot 1 is on. So I know that it's on, but how do I see it? Well, I could see it if you hit graph, it doesn't show up. So I'm going to quit out of there. I need to give you another step. You need to hit the zoom button. The zoom button is right in the center middle, the center top middle. And what I'm going to have you do is scroll down to number 9. And going to number 9, it's called zoom stat. We're using zoom stat because we put our data in the stat button. So by hitting zoom 9, well then it immediately goes to the data that you put in the stat button. So that's easy to remember by thinking of it that way. We use the stat button to put the data in, use zoom stat to make the scatter plot show up. So now we have this scatter plot, and we can see from this that it's going in a positive linear relationship. You can see if you imagine a straight line through all these points, that you're going positive, right? It's increasing from left to right. So it's a positive relationship. And most of the dots seem relatively close together. So I would say that's a pretty strong relationship. Okay. Now, if you wanted to change up the way the window looked, well, you hit the window button. And this is where you can change the X-min, X-max, Y-min, Y-max. So if you wanted to show a little bit more to the left, you could make X-min 0. If you want to go to the right more, maybe you can make this 225. And then if you wanted to go up higher, well, you can make the Y-max like 7, for example. And then if you want to go back to the graph, do not hit zoom 9, just hit graph, and then it makes your adjustments that you've made. So you can see it expanded up a little bit more, and we went a little bit to the left and a little bit to the right. Okay. If you really want to zoom out far, you could put like -10 and 300, then hit graph. You can see I really zoomed out, but I zoomed too far out. I don't want to do that, so I'm gonna just hit zoom 9, and zoom 9 will bring you back to where you started. So zoom 9 is the nicest way to look at it. Okay, now I said I will also use LinRegTTest. So now what I want to do, you hit the stat button again, go to tests, and then we have to go to letter F actually, and letter F will be all the way towards the bottom. So stat, tests, I'm gonna arrow up to go towards the bottom. Letter F is LinRegTTest. So let's hit enter on there. It's gonna ask for the X list, well, list 1, and Y list, list 2. Did we have any frequencies? No, so do not touch that, we'll just leave it. And then this is asking about beta and rho. We will make that not equal to 0, so leave it on the default. So make sure you change it to not equal to 0 if it was on any of these. Just change it to not equal to 0. Now this is saying regression equation, and this we could use to put the regression equation into y equals if we wanted, but I'm going to skip over that. We do not need to do that. So then I'll just hit calculate. Now you'll see that we have y equals a plus bx. Now really we are creating our prediction equation y hat, our best fit line. So I will put y hat on it equals a plus bx. Now you'll see beta not equal to 0 and rho not equal to 0 showed back up. Now this comes to an idea of hypothesis testing, and that is some deep, heavy theory stuff, so I'm not going to go into detail with that. And then here's our t value, our test statistic t value, that also comes from hypothesis testing. I won't go into detail there. Our p value, this helps determine if r is significant, and the p-value is actually really, really tiny. You see e -4, that tells you to move the decimal place left 4. So it's going to be really, really tiny p-value, so r is significant using the p-value method. Now, what I'm interested in is everything down here. So degrees of freedom is 8. Well, that comes from 10 data points, and you subtract 2, gives you 8. Okay, a equals -0.6274. So I'm going to write that down here. So y equals -0.6274 plus, now my b you could read off there as 0.0226, and then I'll multiply it by an x, our variable x, and we have our regression equation. This is our best fit line. And what I'm also interested in is our correlation, r equals 0.910. This correlation tells us the direction and the strength. And the direction, if we go back to graph, I'll go to the graph, the correlation is positive. Positive tells me that I have a positive slope here. And you can see that matches with my slope in our line right here. It's positive. So our direction is going positive. Now the strength. The strength, all these dots were pretty close together. We're closely compacted, so the strength is strong. Also, our correlation value can only be between -1 and +1. And r is very close to +1. And the closer you are to 1 or -1, the stronger your relationship is. So it looks like we have a pretty strong relationship going on in this example. Okay, so that demonstrates everything with the technology part. Thank you for watching.